Hello there, my name's Alaydriem, and welcome back to another Minecraft Bedrock Redstone tutorial. With me, your favorite cardigan wearing Minecraft character. And in this episode, we're going to be doing something a little bit different. We're going to be talking about Boolean Logic Gates, a little bit about Boolean algebra, but instead of using transistors and diodes and vacuum tubes, we're going to be using Minecraft Redstone. And if you already know what Boolean logic is and how to do this and how everything works out on a circuit board, go ahead, like the video and have yourself a great day. But if you're new to electronics or circuitry or Boolean algebra, or just want to know how some of these basic principles work, make sure you stay liked and subscribed because I have lots of other cool content for you that you might like as well. Now, the Boolean logic gates that we were talking about in this episode are going to be the most basic and foundational ones, and not NAND or NOR and XOR, the basic gates that construct nearly all more complex Boolean logic circuits. And if none of those words are familiar to you, don't worry, this is the video for you. We'll be explaining everything. So what exactly is Boolean logic? Well, you can think of Boolean logic a lot like a function. Whether that be in mathematics or programming, you have a function that takes a given set of input parameters and then generates an output for you, depending upon how that function is constructed. And Boolean logic is just a vastly simplified version of this. You have an input, true or false, and then it generates an output. And a logic circuit is just a physical representation of that Boolean math. So to get started, let's dive into what an AND gate looks like inside of Minecraft. We're going to start with 3 blocks right here with a input going into each of them. I'm using repeaters just so that I have the max signal strength of Minecraft. 2 torches on top with a piece of redstone dust between them, torch here in the middle, piece of dust, and then a lamp. A lot of this circuit is really just to help you visualize it. This is if you're thinking about what an AND gate looks like on a diagram, this is more or less what you have. Now, an AND gate will return an output if and only if both of these inputs are turned on or the signal is raised high. So as you can see here, if that signal is on but the other's off, this lamp will not turn on. But the second we turn on both of these inputs, we have an output. So an AND gate takes 2 inputs, and if both of them are true, high, 1, whatever it may be, then this will output a signal. And as you can see here, we can simplify this in Minecraft just by attaching these levers. There's lots of different ways that you can work with this construction. Now, the next gate that I want to talk about is the NOT gate. The NOT gate may also be known as an inverse gate, and it does what you might expect. It will take a given input and then it will invert it. So as we can see here, if we place down a single block with a torch in front of it, and then just for the sake of construction, pop a torch down. If the input coming into this block is on or it's high, then the output will be off. And similarly, if there is no input or the input is low, then this light will turn on and off inversely. Now, these 2 logic gates, when combined together, create one of the most important logic gates, which we will be using to construct all of our other logic gates in this episode, the NAND gate. And for the sake of simplifying things here in Minecraft, we're going to have a signal coming into our NOT gate, and this is now an AND gate. And an AND gate you can think as not AND. It is the inverse of whatever the output of AND is. So we can simplify that another way by saying the output of this will be on as long as both inputs are not on. So as we can see here from this construction, our redstone lamp is on, both of our switches are off. If we flip either one of these levers independently, that lamp will stay on. But the moment that we flip on this second lever here and have both inputs to our AND gate turned on, our redstone lamp turns off. And from this singular gate that we have represented here, we can create every other logic circuit that there is. Now, this circuit in Minecraft is rather bulky, so we can simplify the entire NAND gate by creating our AND gate circuit here. Instead of throwing a torch here on the middle, we just throw down a line of redstone dust. So as I'll demonstrate here, I'm going to pop down some levers, throw a piece of redstone dust right down here, and then throw our redstone lamp. And as you can see here, this is the exact same. They operate and function exactly the same. If one input is on, this stays on. If both are off, it stays on. And if both levers are turned on, then we have ourselves a inverted output. So this is, again, is just the simplified construction of this inside of Minecraft. And as I mentioned earlier, with a single NAND gate, we can use NAND construction to create every other logic gate there is. So as an example, we're going to go ahead and build a OR gate out of NAND gates. So we're going to start by building 2 NAND gates right here, and then we'll have a third NAND gate up here, which will be our output. So let's pop down some redstone dust real quick. We're going to go ahead and get some torches on, make our NAND gates real quick, and then we're going to take the output of each of these NAND gates and tie them into one side of our NAND gate that we have up here. Just pop those torches down real quick. And then over here, just to keep things simplified, we're going to bind these 2 inputs together and then have that be a single input with a lever plop down right here. And it looks like I'm missing one little piece of redstone dust over here real quick. So we'll pop that down, and now we have ourselves an OR gate. So this is composed of 2 NAND gates, each with their input tied together, that feeds into another NAND gate, which then generates our total OR gate. This is what it might look like on a circuit trace, but an OR gate says if this switch is on, if either of these switches are on, then we have an output that is on. And similarly, if we have both the switches on, we still have our output turned on. Or another simplified way of saying this, if A or B is turned on, then the output is turned on as well. Of course, if you were building Minecraft redstone circuits like this, your Minecraft circuit would be ginormous. So we can simplify this OR gate down in Minecraft by placing down a block here, throwing in an input on either side, popping down a redstone line with a lamp, and then just throwing our inputs right here. So this is the exact same thing. If either of these inputs is turned on, then the lamp turns on. And if both of them are turned on, the lamp is on. And then if neither of them are turned on, then the lamp is off. And as you can see, these function and behave the exact same way. Now that we know how to make an OR gate, we can now make a NOR gate, which is what you might expect. It's not OR. If not A or B, then we will have an output. And we can do this simply by inverting the signal, which we can also represent by using another NAND gate with that output tied to this redstone lamp right here and 2 touches put down. And then if we just bind the input of this NAND gate right here together, we basically just created a NOT gate. And NOR gates are unique because you only get an output from a NOR gate if both of your inputs are turned on. So if either of your inputs, if any of your inputs are turned on, then your resulting signal will be off. And as you can see here, once we turn both off, then our signal turns on. And of course, in our simplified circuit that we have over here, we can simply pop this out, throw a NOT gate on top of that, and then throw a line with a lamp back on. And as you can see here, this is the exact same thing, just a little bit more compact. Now, the next foundational logic circuit on our list is the XOR gate, which basically says if the input for either of these inputs is turned on, but not both of the inputs are turned on or off, then we get an output. So if A or B, but not both are the same. And to build that, we can make a simple modification here to our NOR gate. So what I'm going to do is remove this input line over here, and I'm going to tie these 2 middle inputs together so that they create a single input. And this is going to feed into, I'll give you one guess, a NAND gate. So we're just going to build that real quick over here. Then we're going to similarly tie the inputs of these together so that we have a single input coming into our circuit. Go ahead and just bridge that over as shown here. Then we're just gonna pop down a line, and let's make those a little bit close together. Then we can throw down a lever. And then of course, we don't need this second NAND gate all the way up here. So we can just get rid of that, pop down our redstone lamp again. And as we can see here, this is what our circuit looks like. So if either of our inputs is turned off, in this case, both of them are, then our lamp is off. And if we were to turn either of these inputs on, but not both of them, then our lamp would turn on. So go down here, give this lever a little flick real quick. As you can see, that lamp turns on, turn that off, do the same thing over here, lamp turns on. But if we turn both on, then our lamp turns off. And again, in Minecraft, this large, hairy, ugly logic gate can be simplified down as shown here. We're going to start by placing down 3 blocks in a row here with a block extending from the middle. Go ahead and place down a torch on each of the corners with a piece of redstone dust there. Place down another piece of redstone dust on this, torch, torch, torch. Then we're going to come over here with a piece of redstone dust in the corners, place down blocks in front of those torches. Then we're going to place down dust on top of those, and then torch, torch. Then we're going to connect that with a piece of redstone dust, another piece of redstone dust, and then a lamp to help you visualize. Then in the back here, we're just going to pop down some repeaters with some pieces of levers. And then as you can see here, we have the exact same construction. So as you can see here, both of our inputs are off. Flip one switch on, lamp turns on, another switch on, lamp turns on. But if we turn both on, then our lamp output is off. This is, again, just a drastically simplified footprint of the exact same system that we have here using our NAND gates. And finally, the last logic circuit that I want to showcase is the XNOR gate. So you can think of this as not A or B, but not both, knotted or inverted. So using our simplified circuit, because I think we've gotten a little too large with that circuit over there, we can do that simply by inverting this signal that we have here. So we get ourselves this lamp out of the way, extend that line, then throw down a NOT gate in front of this with our lamp. We now have ourselves our XNOR gate. So both of our inputs are off. If we turn either one of them on, then our lamp will turn off. And then if we turn both of them on, our lamp will turn on. So the output is only on if both inputs are off or both inputs are on. And those are the foundational logic gates that I think you should know. So I hope that you enjoyed this video, or at least found it useful. I know that this is a little bit different from most of the Minecraft Redstone tutorials that I build, but I think understanding how these foundational logic gates work help you have a better understanding of how to use them and help you apply them a little bit better. So as always, thank you so much for watching. I always appreciate you guys interacting with me down in the comments or liking the videos. If you have any comments, feel free to leave them down as well. And I will see you in the next episode. Goodbye.